All right, and hello, and welcome back to our OneClass channel. Again, I streamed for about an hour at 10 a.m. Eastern Time, and now I'm back for another session at 12 p.m. Again, my name is Joey. I'm going to be your OneClass math teacher for this session for the next hour. And what we're doing is that we are here at OneClass. What we're doing is provide online lessons, online free lessons for secondary school students, particularly in subjects such as math and chemistry. So, with my background, what I am is I'm a secondary school teacher, specifically in chemistry and in science, as well as hopefully in math as well, coming September. And what what I'm going to do today is I'm going to go over some frequently asked questions about secondary school level math. So in the 10 a.m. stream, what I did was I did questions in basically kind of grade 9 math, pre-algebra, algebra 1. And now what we're going to do is we're going to do some grade 10 math. The grade 10 math in the US would kind of equate to late algebra 1 and algebra 2 sort of questions. So I got a lot of requests to do quadratic equations to go over some grade 10 math. So I'm going to do that for you for the next hour. So if you're tuning in for the first time, thank you for watching our stream. Again, if you have any questions, let me know anytime at the chat, and I'll try my best to answer those questions as we move forward today. So without further ado, let's get started on our 10 questions that we have for today. So our first question comes on here. It says here, where's my pencil? There it is. What substitute should be used to rewrite 4x to the power of 12, I believe, minus 5 to the power of x minus 14 as a quadratic equation? So I'm saying here, 4x to the 12 minus 5x, this is number 1. Let me state that. That's number 1 here. So 4x to the power of 12 minus 5x to the power of 6 minus 14 equals 0. So that's going to be my my polynomial for this question, for my first question here. So I want to rewrite this as a quadratic. Rewrite as quadratic. So what substitution would I need to make it as a quadratic equation here? How would I rewrite this polynomial in terms of a quadratic? So what we're going to do is, again, take a minute to think about this question, and then we are going to take it up together and do the solution together. So take a minute to do that, and yeah. So we have x to the 12, right? So remember, recall our exponent laws. When we add our exponents together, or we're subbing in our exponents together, if we're taking the power of something. So for example, if we have here, this is x squared here, and then if we times it by x squared, we would add the exponents, right, to get x to the 4, right? So that's just a little review of exponent laws, right? So that maybe this is what we need to solve for this question here, right? Or is it? I'm not sure. So if we want to rewrite this as a quadratic, what we have to do is I need to rewrite it to something to the power of 12, right? So I'm gonna do this in blue. I'm gonna say that I'm gonna make a new equation with the value u. So this is gonna be u. I'm gonna let u equal to something. So let's do that. So all I'm doing is I'm just changing simply my my exponent here, right? I want this to become a quadratic, like u to the u, or I want it to become x squared, right? And then minus x minus something, right, equals 0, right? The 14 here stays constant, right? I don't have to change the 14 here. So let me write 14 equals 0, and I'm just solving for whatever this blank is and this blank is, right? These are the two blanks I'm looking at. So how would I get from 4x to the 12 to x squared, right? What would I have to do? Like, this difference is, you can say that this is a difference, or if I'm doing x to the 12, I can divide it by x squared, right? Or sorry, I'm not dividing. No, sorry, I'm not dividing. Basically what I'm doing is I'm taking these two exponents, and what I'm going to do is I can I can take it to another exponent. So what I can say is I can do x and x to the power of 12, and then I'm going to divide it by or take it to the power of something so that this question would equal x to the power squared, right? So what I want to do is I want to actually I want to take it to another power. Basically, I would do this x to the power of 12 to the, and I would to the negative negative 6 would equal x squared. So I would do something like this. To the negative 6. Sorry, I would do x. Sorry, I wouldn't do that. I would do x to the power of 12 divided by maybe x to the 10 to x squared, right? And that's what I'm doing here because I'm subtracting my exponents to get x squared, right? So basically what I would have to do is I would have to divide this by x to the 10, right, to get x squared, right? But if you look at this substitution, it doesn't work for this one here. Right, it doesn't really work, right? Because if I divide 5x to 6, if I divide it by x to 10, I'm going to get x to the negative 4. So this doesn't make sense here. So I have to find another substitution for me to get this. And the only the only valid solution in this case here is, instead of doing this operation, what I'm going to do is I'm going to do something called a direct substitution. So what I have to do is I have to let, I'm gonna do some red. I have to say that I'm going to let in this case u or some other variable equal x to the 6. And why I chose x to the 6 was because of this this polynomial here, right? Because I want this here to become u, right? So if I said let u to the x to the 6, I would get something like this. I would get 4, and I get u. I get 4u squared minus 5u minus 14, and that's gonna be my actual answer for this problem. And the reason why is that if I had u squared here, and I said let u be x squared, right? And x squared to the power of to the power of 2 here would equal x to the 12, right? So this here is exactly the same as the squared I was talking about before, right? This degree I was talking about before. So in that case, I would get this here would be my problem. Right? I need to let this u substitution here. So I would get 4u squared minus 5u minus 14, and this here equals 0, right? And this here is my quadratic equation, right? You can see here, this is my highest degree here is squared, right? So this here is my correct answer, 4u squared minus 5u minus 14, and I did this u substitution. So let u equal x to the power of 6 here. So let me see what they did here. So quiz quadratic equation is quadratic, the highest number is value 2. That's good. And then they did now the given equation is 4x12 minus 5x to the power 6 minus 14. Highest power variable is 12, so to make it quadratic, we have to replace it by y squared. So they did y squared instead. That's fine. And then therefore x to the 6 equals y, and x to the 12 equals y squared. So it'd be 4y squared minus 5y minus 14. This is good because they did a substitution of y equals x to the 6, perfect solution. So this here is a perfect solution and analysis. And because that's exactly what the same here, I actually replaced it with u instead of y, totally fine. So this solution here is correct. Okay. Let's look at number 2. Number 2 says that if the discriminant of the quadratic equation is 6, what statement describes the roots? So here 2, if discriminant of quadratic equation is 6, which statement describes the roots? What statement describes the roots? Okay, so here it says there's only one real root. There are 2 complex roots. There are two complex roots. There are 2 real roots, and there's only 1 complex root, right? So what is this discriminant, right? Remember, the discriminant here is simply, remember, our quadratic formula, right? Our quadratic formula states that it's negative b plus or minus square root of b squared minus 4ac all over 2a, right? So that's here is my quadratic equation here. And I have negative b plus minus b squared minus 4ac, right? This here is my discriminant, right? Discriminant. So if I'm saying square root of b squared minus 4ac is my discriminant, so this square root of b squared minus 4ac equals 6, or my discriminant, what does that statement describe, right? What does that say about my roots? remember I'm solving this x equals, I'm solving for something here, right? So if my discriminant equals positive in this case, or positive, or it's positive in this case, I can say that this entire thing here is 6, right? So basically I can rewrite my quadratic equation to look something like this. So I would have x equals this negative b plus minus 6 over 2a, right? Negative b plus minus 6 equals 2a. And then what I can do is I can split this up, right? I can split this up into positive and negative, right? So I'm going to have here x would equal negative b plus 6 over 2a. And this here is negative b minus 6 over 2a. And in this case, both of these answers here will give me a real root or a complex root, or only one real root, right? In this case, I have here negative b plus 6 and negative b minus 6. These two will give me different answers, right? I'm going to have a different numerator. I'm dividing by the same denominator, but I have a different numerator, which means I'm going to get two different answers here. So I'm going to get two different, I'll say different values for now, which means it's either B or C in this case, right? It's either B or C, and you have to determine if these roots are complex or real, right? In this case, it's actually a real root, right? If we had a complex root, my discriminant would be an imaginary number, right? If I had b squared minus 4ac, if it was to be a complex root, this would have to equal I, or some type of value times I, or something like that, because my inside the square root here would be a negative number, right? Negative value. I'm square rooting a negative value, which means it's a complex number here. So if it's and in this case, it's just this equals 6, right? Which is not a which means I don't have a complex root, which means my answer here is I have two. So in this case, this would be also a real roots, right? Real roots, which means my answer here is C, right? And here so this actually matches what they said here. So the explanation is discriminant of the quadratic gives us the nature of the root. That's good. We don't know if it's complex or real. B squared minus 4ac, that's correct here. If d is greater than 0, the quadratic has two real roots. That's what we had here. If it's less than 0, if it's a negative number, it has two complex roots. If it's equal to 0, then it has equal roots, right? It has one real. It has both my x-intercepts are the same. If d equals 6 greater than 0, hence it has two roots. So I like this solution. This is perfect solution, and in this case, it's the logic here, right? So this question here is correct. And this here was question. This here is question 2, right? Question 2. Solution is correct. Nice. So this is a new question now. This is question 3. So what is the radius of the circle whose equation is the following? So I'm going to write this way. This is x squared plus y squared plus 8x minus 6y plus 21. So what is the radius of the circle whose equation is this, right? Okay. So first, how do we solve for we know that this is a radius we know that this is the equation of a circle, right? Remember, the equation of a circle looks something like this. It looks something like x squared plus y squared, plus y squared equals some number, right? Or 0, right? It doesn't really matter. I have both x squared and y squared. This is the equation of a circle. Equation of a circle. Okay, so now it's like now we gotta think. Okay, how do we solve for the radius? What is the radius of the circle, right? So in order for us to solve for the radius, what we're doing is we need to break this down into a factored form. So something like x plus 4, x minus 4, right? Kind of like the roots there. The roots in this case will give us the radius of that circle. And what we're going to do is we're going to have to simplify this polynomial to get us that equation here. So what do we have to? So I'm going to look at the solution here, and what we're doing is, again, we're given this equation. That's good. So at first we're going to we need to write this out in standard form. That's what we're doing before, right? So it has x minus s1 squared, y minus t1 squared. Don't worry about s and t. There's values in this case, and d1 here is our is what we care about. That's what we're going to get for our radius and our diameter, right? So that's kind of that. So this here, we have to get some number here, and we have to manipulate this polynomial to get that solution. So that's awesome. So what we're going to do is we are going to, so what they did here was therefore they wrote this down and they did x squared plus 2 times 4 x plus y. So what they did was they grouped them together, right? So they grouped, this is here x squared. So I have x, I'm going to do this in black, sorry. And I like what they did here. I'm collecting like terms, right? X squared plus, or I'm rewriting them to make them fit into the both sides, minus 6y, and then I'm gonna put 21 on the other side here, plus 21 equals 0, right? And then what they're doing, actually, let me put 21 on the other side actually. So this here would be equals negative 21. I'm subtracting both sides by negative 21, right? Negative 21. And then what they're doing is they're collecting like terms. They're going to factor out the first two terms here. They're going to common factor both sides, right? So I have x here equals x plus 4 plus y is y minus 6. Yeah, y minus 6 equals, and then 21 here, right? Y minus 21. And then in order for me to make it like a squared term here, what I would need to do is what they're doing is they're completing the square, right? So they're adding the square of 4 and the square of 3 on both sides, right? So they're doing something called completing the square. So they're completing the square for this first one, and then the second one for this case. So in this case, I would have to do, in order for me to make this term a perfect square trinomial, I have to do something like x here is x plus 4, and I'm taking half of 4 times the 4 divided by 2 squared, right? So in this case, it would be minus 4 plus 4, right? So it'd be, this would be minus 4 plus 4. And then for y here, it would be 6 divided by 2 is 3. 3 squared is 9, right? So they're adding the square of 4 and the square of 3 to both sides, right? So that's what we're doing here. So how I would write this is I would write this as y minus 6, and then basically I'm doing I'm adding this side minus, so I'm adding the square of 4 plus the square of 3. So that's 16 plus 9 here, which is 25. So it's 25 minus 25 here equals 21. So that's what I'm doing in this case. In this case here. So I'm adding both sides by 25 here. And then, oh, sorry, this here is equal to negative 21, right? Yeah, this is negative 21. Sorry, I messed up here. This is negative 21 because I moved the 21 to the other side. And then what I can do is I can group this together. So x plus 4. So this now becomes, and if you took the 25, if you split it up to 16 here, so I'll do this in blue. If you split this up to 16 here, and 9 here, you would get actually a perfect square trinomial by putting the 25 back inside the bracket. So you get x plus 4 squared plus y minus 3 in this case, or squared, because I'm dividing 6 by 2 to get negative 3, equals, and I get minus 21 plus 25, right? Which means this here equals 4. So I have x plus 4 squared plus y y minus 3, plus y minus 3 squared equals, this is 4, right? And then what I have to do is I have to, I want to make the exponents the same, right? So I have to find out, okay, what is the, something squared equals 4, right? What squared this equals 4? I would square root that right side as well. So I have x plus 4 squared plus y minus 3 squared. This would equal the same thing as 2 squared, right? And the radius here would be my number here. So therefore, radius is 2 units. And they did something similar to here. The solution was great in terms of what they did was they added the square to both sides, but they weren't as specific as to like how did they get this number. Like I wrote here, I got it by adding 16 and 9 here. That made 25 here, right? So they did this kind of sort of like here, and then they moved it algebraically, which is fine. But from this step to this step, they didn't really show how to complete the square. I didn't show it for the sake of time, but this is actually perfectly fine as well. Because I could have rewritten this as I'll do this in blue. They could have rewritten this as if I had like x squared sorry, if I factor the x here, I have x plus 4, and then it would do plus 4 minus 4, and then I would take out this negative 4 out of the bracket to make 25, right? That's what I'm doing here. Or sorry, I would do, so this would be 16, not 16 minus 16. Sorry, not 4. This would be 16, and then I could have done the same thing for the y. 6, because then 16 plus 9 would equal, or sorry, negative 16 minus 9 is negative 25. So that's how they got the 25 here. That's what they're doing here. So what we're doing now is we are going to, so I'm going to look at the solution. Again, the solution is correct. They did miss a couple steps here, but I'm going to say that this is a good solution. It's perfectly fine. It's a good, great solution and analysis. So I'm going to write that down. So the solution here is correct. So I actually, so this is my bad on this problem. What we're gonna do is actually we're going to this number 4 is actually the same question as what we did previously. So I accidentally uploaded the same question for this one. So we're just gonna skip this question. But what we're gonna do is let's just verify this super quickly. So this is the same as 3. Right? Same as 3. And well, I'm just going to verify the solution together. So I won't do the same steps here. We know that the standard solution equation of a circle center K is good. I have x minus h squared, y minus k squared. That's good. I have this. So what they're doing is this is great because this here they did they're completing the square, x squared plus 8x, and then what they're doing is they have they had, what was it, 8x? Did I write this down properly? Oh, I didn't write this down properly. My bad. This here was 8. Sorry. That's why my math was weird. 8 and 8. I wrote this wrong. When I factored the x, it was 8. So 8 divided by 2 squared is 16. Sorry, that's my fault. So this corrected me. That's good. But this here was the step-by-step solution that I wanted the other solution to be. So this is actually an even better solution here. So radius here is 2 squared, which is awesome. So this here is correct. So even this is actually the same as previous question, but even clearer step-by-step solution. So this here is great in terms of that. So this solution here is also correct. Okay, let's do number 5. Sorry about that. I'm surprised nobody caught me on that. When I factored out the 8 here, I don't know why I had 4. I think in my mind I divided by 2 or something like that. Don't know. So say using the quadratic, solve for this. What is the value of x? So this here is 11 squared minus 4x equals 1. Find the value of x. Okay, so we want to solve for this using the quadratic formula. So in order for us to do that, I need to make one side 0, right? So I'm going to bring this 1 to the other side. So 11x squared minus 4x, and this would be now negative 1 equals 0, right? I'm subtracting 1 from both sides. Now we have to do our quadratic formula, right? We have here, this is x equals is negative b plus minus square root of b squared minus 4ac all over 2a, right? And we're really familiar with this already in terms of the quadratic formula. And now we're simply just plugging in, right? So we have x squared equals negative b. I have negative 4 here. Minus 4 would give me positive 4. So 4 plus minus, this is square root of b squared. So b squared is negative 4 squared, which is simply just 16. Minus 4 times a is 11. C here is negative 1. So 4 times 11 times negative 1, all over 2 times 11, right? 2a here. And then what we're going to do is I'm going to simplify the square root first. So this here equals 4 plus minus square root of, I have 16 minus 4 times 11 minus 11 here, right? So I'm going to do 4 times 11 is 44 times negative 1 is negative 44. All over 2 times 11 here is 22, right? So that's going to be my question here. I'm going to simplify the square root even further and say that it's a 4 plus minus, and then 16 minus 44 would give me 16 plus 44, right? Which is simply 60. So this is root 60 over 22. And now what we can do is we can split this up into plus and minuses, right? We can say that our so here our first root would be 4 plus root 60 over 22, and the second root here is 4 minus 60 over 22. So those are going to be my solutions here. I could plug this into my calculator to get me a decimal. I can do that for you. So I'm going to get, let's see. So again, these are my solutions here, right? I don't think I can It's 4 plus, this is root 60 over 22. This here would be 0.53. And this here would be let's see, is negative 0.17. So these here will be 2 roots, and that's going to be our final answer for this question here. So they did the exact same thing with ours, with this quadratic equation. This here, as you can see, equals 4 plus minus root 60 over 22, which is great. And what they did was they actually took it a step further, right? What they did was they actually simplified this radical to give you something like 4 plus, and then they simplified this root 16 multiplied by root this is root 4, right? So that's what they did here as well. And this would give us 4 plus, and then this is 2 root 15 over 22, right? And then what they did was they factored out the 2 out of the numerator, so you get 2 plus, and this is just root 15 over 22, and this would cancel out to get you 2 root 15 over 11, right? And that's what they did here for both sides here. So they actually even took it a step further, which is awesome. So this solution is perfect, great solution, no complaints here. So it's perfect solution, great step by step. I liked how you simplified the radical even more. Solution is correct here. Sweet. Okay, so that was number 5. This will be number 6 now, and we're just about the half an hour. We're slightly above time, which is great here. So this is 6. So it says here the quadratic function h of t equals negative 16t squared plus 150 models a ball's height in feet over time in seconds after it is dropped from a 15-story building. From what height in feet was the ball dropped? After seconds rounded to the nearest hundredth did the ball hit the ground? So this is height at a specific time equals, this is negative 16.1 t squared plus 150. And that's going to be my equation for this problem here. Negative 16.1 t squared minus 150. So it's asking from what height in feet was the ball first dropped. So when we're asking from what height in feet was the ball first dropped, I would have to plug in, I'm assuming that at time 0, the ball is dropped, right? Because if you think about it, let me use my pencil, for example. So this here, you can say it's a ball. If I drop my pencil like so, if I drop my pencil like this, what time it's going to record time the moment I drop the pencil. So at time 0, it'd be from which height, right? So at time 0 is going to be the height at which the ball is dropped. So at time 0, and then it's going to fall. So and then time starts now, and then once the ball hits the ground, the height would be 0, right? Because the ground is 0, 0, and then I would get some sort of time, right? So we're subbing in HE at 0 would give me the time at which, or the height at which, sorry, the height, let me rephrase it. If I sub in time equals 0, it'll give me the initial height. So that's what I'm going to sub in that. So H at 0 equals negative 16.1 t squared, right? And if it's t is 0, so 0 squared plus 150. Anything times 0 is 0, so this cancels out, which means h at 0 equals 150, and this is in feet, right? So here it means that my ball was first dropped at a height of 150. So this is 6a. 6b was asking how many seconds rounded to the nearest hundredth did the ball hit the ground, right? So h at t equals, we're going to rewrite my problem here, plus 150. And then what I'm going to do is I'm going to sub in 0 for my height, right? Height 0 is when the ball has reached the ground, right? So I'm solving for my time now. So if height was 0, I'm subbing this here as 0 equals negative 16.1 t squared plus 150. Yep. I'm going to now isolate for t as my variable. I'm going to subtract both sides by 150. So I get 150 equals negative 16.1 t squared. Now what we can do is, again, I can divide both sides by 16.1, my negative 16.1. Sorry, negative 150 minus, divided by negative 16.1 equals t squared. I'm going to take out my calculator to do that calculation. So negative 150 divided by negative 16.1. Again, my negatives are going to cancel out in this case. And I'm going to get 9.3. So this is going to cancel out. And then I get t squared equals is 9.3. I'm going to round it to maybe nearest thousandth here and say 3.17. And then what I can do is I can square root both sides to get t, right? T would equal, I would square root both sides, to get my answer. Square root of 9.317 would equal a 3.05 as my answer. And this would be in the seconds. So this here would be my time when the ball hit the ground. So after 3 seconds, my ball has hit the ground. So let me check my answer here. So let's go from here. So again, h at t, they plugged in 0. That's good. This should have been 0 squared, actually. 0 squared times 0 squared plus 150. That's all for you. That equals 150. That's good. They set 0 to find the height. So 150 is correct here. They set, for part B, they set 0 as the height. That's good. This here, they should have canceled the negative 16. Negative 16 shouldn't cancel out. That's totally fine, though. And then 3 seconds, 3.05 seconds. That's good. What I wanted, actually, even for my solution, was I would have said this is plus or minus seconds here, and I would say since t cannot equal negative 0.3 seconds, then 3.5 seconds is the answer. Here. But this here, approximately 3 seconds, the ball hit the ground. Sweet, great solution. And step-by-step process. So this here was question 6. Okay, and let's look at question 7. So let's see here, which statement is true about the factorization of 30x squared plus 40xy plus 51y squared? So it's 30x squared plus 40xy plus 51y squared. Okay. So take a moment to think about this problem. Again, you're given 4 options here. The factorization of 30x squared plus 40xy plus 51 squared is 10, and then 10 3x squared plus 4xy plus 5xy. The polynomial can be written as a product of a trinomial and xy. The greatest common factor of the polynomial is x squared y squared. The greatest common factor of the terms is 1. So what is true about the factorization of this? Okay, so let's break this down into, let's look at all the multiple choice here. So let's look at A here. So A. So it says A here's the factorization of 30x equals this thing here. So it was 10 times 3x squared, x squared, 3x squared plus 4xy plus 5y, right? Or y squared. Okay, so if I factored and use distributive property, I would get something like this. I would get 30x squared, because I'm multiplying it by this. 30 times 4xy would be 40xy. And then 10 times 5 here is 50y squared. So 30x squared plus 40xy plus 51y squared is not equal to 30 squared plus 40xy plus, because this here, right? 50y squared versus 51y squared. So in this case, option A is incorrect. So A is incorrect here. Okay, that's fine. Let's look at option B here. So B here says that the polynomial can be rewritten as a product of a trinomial and xy. So let's get back to this one, because I could do the work to look at the trinomial here, but I'm going to do C and D first, and maybe use process of elimination. Let's get back to B here. So let's go back to B here, and let's look at C here. So C here says the greatest common factor of the polynomial is x squared and y squared. So in this case, when we talk about greatest common factor is x squared and y squared, it's actually not correct, because what it is I have here if I look at 30x squared plus 40xy plus 51y, x squared and y squared it's not common for all three of these terms, right? Not all of these terms have x squared and y squared, right? So if I factored out x squared and y squared out of this thing here, I wouldn't, for example, my first term here, 30x squared doesn't have a y squared, 40xy I'm missing x and y, and the 51y squared I'm missing x squared, right? So C here is incorrect because not all terms have, and then x squared, y squared, right? So C is incorrect. And D here, the greatest common factor of these terms, 1. D here in this case is correct, right? Because the only thing common between these three terms is 1. So this here is actually correct here. So let's go back to option B. B here is incorrect here. And why is B incorrect here? The polynomial can be rewritten as the product of a trinomial and x and y, right? And what I can do is I can actually, if I were to factor this trinomial out, I would get basically some number times x here, times x plus, and then I would get some xy and then some y, right, to get a perfect square trinomial. And so it's not rewritten as trinomial and xy in this case, because a trinomial you would get something like this. It would be like ax squared plus bx plus c. And then it would be multiplied by xy, right? Which makes no sense, because if you multiply these two, you would get ax cubed plus ax cubed y plus bx squared y plus cxy, right? Which makes no sense, right? This here does not equate to my 30x squared plus 40xy, right? Because this here the degree is 3, this here the degree is 2, which means B is also an incorrect answer. Which means the only answer that's correct here is D, right? Greatest common factor is 1 here. So in this case, D is correct. And that's what they wrote here. Option D is correct because given this, good. Option A, yes, 50 compared to 51. That's what I did over here, which is correct. Option B, there would be a Y in each of the terms, but this is not true. That's also correct here because I have a Y and a Y here. And greatest common factor is not it. That's good. And option D is correct. Sweet. So great. This is a good good solution, and step by step, and step by step. So that's good. Solution here is correct. Sweet. That was 7. Let's do number 8. Number 8. So it says here, which value of m will create a system of parallel lines with no solution? So I want parallel lines with no solution. And I'm given here y equals mx plus 6 and y equals 8x minus 4y equals 12. Mx minus, this looks like a b, but it's actually a 6 here. Let me erase this. Yeah. Mx plus 6, or sorry, this is minus 6, Mx minus 6, and y equals 8x minus 4y equals 12. So the first thing what I'm going to do is I am going to have to convert this here. My second equation is in standard form. I want it to be in slope or y-intercept form. So in order for me to do that, I have to isolate my variables, right? Oh, actually, there's no y equals here, sorry. It's just 8x here. So in order for me to do that, I have to isolate from my y. So let's do that. So I'm going to isolate from my y, which means I want the x has to go on the other side. So I'm going to subtract 8x from both sides. And I'm going to get negative 4y equals, I have 12 minus 8x. And then what I'm going to do is I have to divide everything by negative 4, right? So to leave y alone, so I'm going to have 12 minus 8x divided by negative 4. And this will simplify to, this is simply negative 3 plus 2x, right? Or I can say this is, or I can say if I want to rewrite it, this would be y equals 2x plus minus 3. Oh, sorry, this here is correct, right? Yeah, this is my slope-intercept form here. So I have both of them are now in y-intercept form. And this here, So this here is now y equals minus 3 plus 2x, and I have y equals mx minus 6, right? So I want a parallel lines with no solution. So how would I do a parallel lines with no solution? So in this case, if I remember the concept of a parallel line was simply just lines with the same slope, right? So in this case, if I want lines with the same slope, I would have to have this m here would have to be the same slope as this guy here, right? So this m has to be the same slope, right? Therefore, m would have to equals 2, right? M would equal 2. So y would be 2x minus 6, and y would equal minus 3 plus 2x here. So these two lines would be parallel lines, but how would we make them no solution, right? So that's what they did in this case here. They negative 2 y equals, well, let me check this math here. 8x minus 4y equals 12. So 4y equals 8x. 8x minus 4y equals 12. Okay. Yeah, 4y equals 8x minus 12. How did I get minus 8 here? I don't know about this math here. This math here is incorrect because I need to divide both sides by 4, right? In this case. And in this, what they did was they put 8x to the other side. I would have 12 minus 8x like so here. Or you could do 8x minus 12, that's fine. Or no, it would be negative 8x plus 12 in this case here. So you have y equals 2x minus 8. From this step to this step, it's incorrect, right? I should get something like this. So this here is actually an incorrect solution. The slope is correct is correct with m equals 2 However, when you rearrange, this was 8x minus 4y equals 12, you should have gotten y equals just negative 3 plus 2x, and that's what we got here, right? Not 2x minus 8. So solution in this case is incorrect. But the concept was which value of m would create a system of parallel lines. In this case here, I know that if I want these two lines to be parallel, this slope is 2, which means here m has to equal 2. So that was the main point, but they just did their algebra wrong in this case. So I'm going to say solution is incorrect, just so the system would get that notification there. Okay, let's do number 9. This here is number 9. So what is the standard form equation of the line shown below? So graph of line is going through negative 3, negative 1, and 3 and 2. So I have 2 points. I'm given negative 3 and negative 1, and I have 3 and 2. So take a moment to think about this question. I'm going to grab a drink of water. And what you're going to do is what is the standard? You're going to look at these 4 solutions. You're going to figure out which of these functions would go through these 2 points. So let's take a moment and think about that. So remember, if you have 2 points, what can we solve for first? We can solve for a slope, right? So let me write down the slope equation for you. So this is m equals y2 minus y1 over x2 minus x1, right? And we know that this here is x1, y1, x2, y2, right? So we can solve for our slope first. So maybe take a moment to do that. And if you're in the chat, maybe wave hi again. Let me know that you're here. And yeah, how many solve for the slope here? So if I have y2 would equal, y2 would equal 2 minus y1 here is minus 1 over x2, which is 3. This negative 3 here is minus 3, right? So to get 2 minus 1 here is 3. 3 minus 3 is 6, which means my slope here is half, right? So let's verify our solution here. Our slope is indeed half, which is good. And now let's look at all the options here. So they got the slope correct. I did as well. That's good. So A says that this is y plus 1 equals half x. Y plus 1 equals half of x plus 3. Okay. What we could do is, if I want to isolate to y-intercept form, I have to isolate for y, right? So I would subtract 1 from both sides. And then what I can do, I can do distributive property. I can do, this would be half times x times plus half times 3, which is 3 over 2 minus 1. This was simply half x plus half here, right? That's going to be my my first equation here. In this case, the slope equals this, right? So one could be possible. Okay, so this here could be possible. Let's look at B. B here's y equals, this is also half x plus 5 over 2. Again, my slope here is also half, right? So this here could be a solution as well. Let's look at C here. Is negative x plus 2y equals 1. I would have to isolate for my y, right? So I would have, I would add x to both sides, and then I would isolate for my y here. So I would get 1 plus, or I would divide everything by 2 here, right? So I get a half plus 1/2 x here, which is actually the same thing as A here, which is odd. Very odd here. Because I got the same solution here. Anyways, okay, that's kind of weird. And then let's look at D. Is it x minus 2y equals negative 1? Again, I'm isolating from my y, right? So I have negative 2y equals negative 1 minus x, sorry. I'm subtracting x from both sides. And then I would divide everything by negative 2, right? So if it's divided by negative 2, I would get a half. This would also be plus half x. Again, these two are also the same, right? So this is kind of odd here. So I'm just going to check here. So all 4 of these solutions are valid, right? So what I would have to do is I would have to check some of my points, and for me to do this, I would have to sub in my point into this equation to see if it satisfies that equation here. So I'm going to see what they did here. Find value of b. Okay, so they're finding the value of b for this point here. So that's good. So let me do that. So I have here, for my 2 points, I have y equals mx plus b, right? And I know y, half I solve for. So I know it's half x plus b here. And what I can do is I can plug in any of these 2 points, right? So let's take the point negative 3, negative 1 here. So negative 3, negative 1. So I have negative 1 equals half times negative 3 plus b, and I'm going to isolate for my b. So negative 1 half times negative 3 is negative 3 over 2 plus b. And I have negative 1. I'm going to add 3 over 2 to both sides to get me b. So b here would equal, this is just simply half, right? So in this case, my equation here is y equals half x plus half, right? So that's going to be my my y-intercept equation here. And so b equals half. So we have this sort of equation here. And then what we could do is, like what I did was I actually converted all of these into y-intercept form, but you could convert this into a standard form, right? You could multiply both sides by 2 in this case. So I would get 2y equals, I would just simply left with x, and this was plus 1, and I could manipulate this and send, I could send x to the other side. So I have 2y minus x equals 1, right? So if I look at my values here, 2y minus x equals 1 would look like 2y minus x equals 1. Doesn't really look like a lot of these ones here. 2y minus x. You could rewrite this as negative x plus 2y. So maybe it's option 3 here in this case. But they said option 4 is correct, which doesn't make sense. I have half x. This math is correct here. I'm multiplying 2 by both sides here, which is good. And then I have equals -1. How did they convert 1 to -1 here? I'm so confused. If you bring x to the other side, you get 2y minus x, right? Equals 1. I don't know how this became -1 here. Unless they multiplied both sides by -2. You would get -1. But this was 1, right? This last part is not is not correct here. So with my math, this is 2y minus 1, or you can rewrite this as -x plus 2y equals 1. So in this case, option 3 is correct for my equation here. But if I look at my all my solutions here, I have, if I did the distributive property, I go to half x plus half. This is also half x plus half. This is half x plus half, and this is half x plus half. So actually, I believe that all of these solutions would go through this point here, but I'm going to say that this solution here is incorrect, because this here, algebra, incorrect solution, because the last part was very, very confusing. I don't know how they got 1, and this simply became -1 here. Like, I have, if I move, so if I want this to be -1, I'll have to move this right side. So let me see what they did here. I'm very, very curious. So I have 2y equals x plus 1, right? And then I have -y, so which means I have to move 2y to -1 to get x. And then I have to do, I would have to do, I'd have to move 2y back here, right? So this would be at -1 equals x minus 2y. Okay, so this actually works. This works. I'm sorry, I'm confused. So the math here was correct. This here's 2y. So I have -1 minus 2y. This here is correct. But however, 3 is also correct, right? Because if you looked at my solution here, 3 is also correct, right? I added 2, I multiplied 2 by both sides here. Because I could actually, because this equation here would equal this equation here, right? If I had something like -x plus 2y equals 1 here, I can manipulate this to get this, right? If I moved 2 to the other side, so -x, or sorry, if I moved 1 to this side, I get -x plus 2y minus 1 equals 0. I'm moving x to the other side, so I have 2y minus 1 equals x, and I move 2y to the other side, right? So -1 equals x minus 2y, right? So this here, these two values are also the same here. So again, all of these solutions here are correct. So in this case, incorrect solution, because those 2 points go through all functions, all four linear equations. Because it's incorrect because not only 4 of them here, right? All options have the equation half x. It's half x plus half, right? Plus half, right? So y equals half x plus half. Therefore, both points would go through all the. Therefore, all solutions are correct. So so this is kind of a trick question, because it says all solutions are correct, or not just one, and we prove that using our algebra here. So that's okay here, and then so this is a lot of math. This is number 8 here, right? No, this is number 9, and this here is number 10. So let's look at number 10 here. So say which graph models the function f of x equals -2 over 3 to the power of x. Okay, so this problem is actually a grade 11 problem. So I'm actually gonna do this in another video. So I'm gonna save this and do this for another video, because what we're doing is we have f of x equals -2 times 3 to the power of x, and as a grade 10 student, you actually don't know what this function here. This function here is an exponential function. So you don't learn this till I think grade 11 math, or if you're in algebra 2, you do actually do this graph here. But I'm looking at the graph. And I don't see a graph here attached to this question, but so I can't really answer this question, but I can tell you the properties of an exponential function. Let me open up Desmos for you. But what it is an exponential function looks something like this. And basically what happens is this function here is reflected along the y-axis. So it's going up and down. So it looks something like this here. And this graph is actually very, very much the same here, like this. So it looks kind of like this. The shape looks like this, but again, there's it's 3 to the power, so the base is different. So it decreases even faster, and there is a 2. So there's a vertical stretch in this case in this transformation. So that's kind of my exponential function here. It looks something like this if I were to graph it out. But you don't. However, if you're a grade 10 student, you wouldn't know this function here. But again, I'm not giving the picture, so I can't really answer this question. Question does not state where the graph that it was referring to. However, the provided solution did give an accurate graph. So I'm gonna, and again, I'll do exponential functions probably in a later video when we talk about higher level math. So maybe the late algebra 2 and grade 11 math talks about this function. So maybe when I have a couple questions for those topics, I'll go over that as well. So that's great. And then my last question, I get to do question 11. But remember, my 2 questions are the same here. So I have 4 minutes to do this question. So for what value of x is true, right? So I'm solving for x here. X squared plus 2x equals 24, right? So that's actually so many ways for me to solve for this problem. And one of these problems is I'm going to, you can factor by inspection or factor by decomposition. In this case, I'm going to choose decomposition just because if you don't know how to do decomposition, it's harder for you to do inspection for the teaching purposes. So I'm going to move 24 to the left side. So I get x squared. So move this to the other side here. So x squared plus 2x minus 24 equals 0. I'm going to do something called factor by decomposition. What that is I'm going to take the product of a and c, so of 1 and negative 24, which is negative 24, and then it's going to sum to our b value, which is 2, right? So now I have to take, I'm thinking of 2 numbers that will multiply to negative 24, but add to 2. So give me a second for me to think about that. So I have 2 numbers in my head now. I have here 6 and negative 4. So if I have 6 and negative 4, the product of these 2 numbers indeed equals negative 24. 6 times negative 4 is negative 24, and the sums to negative 2, right? If I add 6 plus negative 4, it would give me 2, right? So I have these 2 numbers. So what I'm going to do is I'm going to break this middle term down into 2 parts, into 6 and negative 4. So I have to say is x squared, I would have plus 6x minus 4x minus 24 equals 0. So I'm breaking this middle part down. If you do 6 minus 4 equals 2, right? So I can totally do that. What I'm going to do now is I'm going to common factor both sides. So I have x squared plus 6x. The common factor here is x. So if I divide that out, I'm going to get x plus 6. And the common factor between negative 4 and negative 24 is negative 4. Divide both sides by negative 4, we'll get x plus 6 here equals 0. So now what I can do is I can rewrite this as x plus 6, and then I can group x and negative 4 together, and I get x minus 4 equals 0. So what I can do is, I didn't actually have to do this entire step, but I could do something called, I could factor by inspection. So what that means is, the moment you get these 2 numbers, what you can do is, I have 6, it's x, 6 plus x and 6 minus 4. So once I get these 2 numbers, I can immediately just write this problem here without going through this step here, because it's going to be x plus 6 and x minus 4. It's always x plus some term and then x plus some term, depending on the signs of your factors here. So after we get that, what we can do is we can apply this rule, right? And remember, anything multiplied by 0 is 0, right? So what we can do is we can break this down into x plus 6. I can set this to 0, and I can set this side to 0 as well. So x plus 6 is 0. If I move 6 to the other side, x equals negative 6. So that's my answer for my first answer. x minus 6. If I put 4 to the other side, here is x equals positive 4, right? So these two would be my solutions for x to be true. So x here can be 6 or negative 6 and 4, and this is going to be my answer for this problem. Let's look at the solution here. We can rewrite this by taking 24 to the left of the equality. That's good. And then what they're doing is they're splitting the middle term, so they're doing factored by decomposition. Took out x and the 4, which is great. You get x plus 4, x plus 6, x minus 4. That's good, which means the required value is 4 and negative 6. Perfect. So perfect solution, and step by step. So this here will end my video at 1 o'clock. This is a perfect timing. Again, I did 10 problems today. I didn't really do 11 because remember my circle question was doubled. So I did do 10 questions. Again, thank you so much for watching this video. Again, today I did a bunch of grade 9 and pre-algebra and algebra 1 math for the first session. And this session was more focused and more geared towards quadratic. So in the grade 10 math curriculum and the later algebra 1 and the algebra 2 curriculum. So again, thank you for watching this video. I'm going to be streaming basically 5 days a week from Monday to Friday, alternating between math and chemistry. So if you want to stay tuned, tomorrow would be a chemistry kind of help session for that as well. So stay tuned for that. And again, as always, have a great day.